Good morning, all. I am Maithri Nadig here. I have Krishnaa Srinivasa, my co-presenter, along with me on this podium. So today we will be talking about exploitation and automated detection of threats present in our modern cloud infrastructure. A brief introduction to ourselves. Krishnaa and I are just a bunch of students. We are bacheloring in computer science. Along with our co-author Mahima, we are interning at a company called Deep Armor. It is a security consulting firm which is making some noise, and we also won one of the most scalable startup recently. For today's agenda, we will be looking in an overview about web application security and cloud infrastructure security. We will also look into the different standards that are there and why we will be going above and beyond certain industry standards. We will also demonstrate few practical attacks for more understanding. Finally, we'll be wrapping up our presentation by looking into our proof of concept for today and the solution for this. So we all know that web application security is the center for any web-based organization. That means you need to secure your web application by securing your APIs, portals, consoles, the cloud infrastructure, and many more. So all of these can be majorly divided into three sections. One, the console, portals, web pages. The second is the APIs, and the third being the cloud infrastructure. So the first two sections are majorly taken care by the developers using a security development lifecycle and the CI/CD for Scrum. The third, cloud infrastructure, requires you to continuously monitor your cloud infra. Usually, developers tend to forget or neglect this, thinking that your cloud service providers are responsible for it. We'll get back to it in a while. Focusing on web application security, we have a 5-step approach for this, that is from S1 to S5, and we recommend you to start it in the earlier stages of your web application development. That is, as soon as your program POR has been initiated, till the deployment and the maintenance part of it. So the S1 that looks into your security architecture, key security attributes, and the security objectives is done usually during the program POR stage. The second, or the step 2, looks into the attack trees that is done during the design phase of your web application. The third is the looks into your focus security code review that is done usually during the implementation phase of your web application. The fourth step looks into fuzzing and pen testing. That is during the pre-launch phase of your web application, and it also gives you a vulnerability report on where you should be focusing your efforts on. The fifth, or the final step, looks into incident response planning. That is during the maintenance or the deployment stage of your web application. So this is our 5-step approach. Along with this, we also have an additional step that is called as CI/CD for Scrum, that majorly focuses your efforts on any new feature that you can add it on to your web application. Along with these, we also look into certain industry standards such as OWASP, SANS, and NIST. Now, let's look into cloud infrastructure security. I would like Krishnaa to take over from here.
Hi, guys. So, cloud infrastructure security basically is securing all your resources and your services that are deployed into your cloud platform. So, the essentials that are required in your security perspective is to provide data encryption. So, the data should be encrypted in rest as well as when it's in transit. We should also provide high availability. So, any resource should be or the services should be available at any point of time. We should also provide with strong authentication by allowing the users to by giving the users only the certain permissions and providing with strong password policies and multi-factor authentications. We should provide customer isolation so the customer's virtual machine cannot be accessed in the private network found. And we can use hybrid cloud as it provides the scalability of the public cloud while the control that the private cloud offers. By having these essentials in your cloud infrastructure, it is easy to securely configure and monitor your cloud platform and provide threat intelligence as well as forensics if any vulnerabilities are found. So when we talk about cloud security, the shared responsibility model comes into picture. It's a security framework that's followed by many cloud platforms like Amazon Web Service, Microsoft Azure, Google Cloud Platform, and other such cloud platforms. So the framework basically states that it's not just the cloud service providers' responsibility to secure the cloud, it's also the customer's responsibility to make sure all your resources and your data is secured in your cloud. So the Amazon Web Service is mainly used and widely used across the globe, and it's also provides more services compared to other cloud platforms. Therefore, we'll be using AWS, that's your Amazon Web Service, as our proof of concept for this research as well as our presentation. So the shared responsibility for AWS has been divided into two parts. That's your security in the cloud and security of the cloud. So security of the cloud is provided by the cloud service provider, here your AWS. So it provides security to your infrastructure, your hardware, your software, your networking. So the AWS makes sure all your services like your S3 or RDS are secure. The second part is the security in the cloud. That's the customer's responsibility. So the customer has to make sure they securely configure the data that they're going to add into these resources. So they have to configure specified permissions for your IAM users, provide strong passwords and multi-factor authentication. When it comes to data, they should configure that your data is always encrypted and not publicly accessible. If we take one example for the shared responsibility model in AWS, so if a customer wants their RDS, that's their relational database service, to be only connected to one VPC, your virtual private cloud, so the customer should configure this, and the cloud service provider will make sure that this RDS is always connected to only that particular VPC. So when we speak about security, there have been a lot of cases that have come up in the headlines about cloud security attacks. Few of them are stated above. So it is found out that almost Facebook lost 540 million records. This has happened because their S3 buckets were made public. It is also seen that whenever there's a cloud breach happening, almost 15 million US dollars have been lost. There's one particular case that created a lot of buzz and that especially piqued our interest. It's of the Capital One's data breach. It is found to have been the biggest data breach till date, and so a hacker gained access to the bank servers of the Capital One, and he was able to compromise almost 100 million clients' user accounts and their credit card details. So we'll talk about this particular case in the next slides. As we saw that a lot of money as well as data is being compromised because your cloud is not secure, we must find ways to mitigate these kind of attacks. So the community has come up with a few standards like your CSA, that's your Cloud Security Alliance, your ISO 27017, and also CIS, that's your Center for Internet Security. So we primarily use CIS, that's the Center for Internet Security, in our POC. So CIS is a non-profit entity that provides us with best practice solutions against any kind of cyber attacks. So CIS provides us with benchmarks that are the recommendations. So these recommendations are the baseline configurations on how to secure your system. So the benchmarks have been divided into 3 sections by CIS. That's your level 1, level 2, and your STIG. So the level 1 is your base recommendations or the basic requirements that are needed to securely configure one system. The second level is your defense in depth. So these are recommendations for organizations where security is a paramount. So if compromise of security happens here, there will lead to a lot of adverse effects in your organization. The third level is the STIG level. It's basically the overlap of the both level 1 and the level 2. So we've primarily chosen SIS as it's a globally recognized entity that provides us with regulated guidelines. So the customer finds more comfort that these globally recognized entities being used. And it also provides recommendations to many cutting edge technologies like your operating systems, your cloud service providers, and your Kubernetes, and many more. So as our POC for today is about cloud infrastructure, we'll move into SIS for cloud service providers. So SIS for cloud service providers basically provides us with recommendations on how to securely configure a cloud account. It provides to many cloud platforms like your Microsoft Azure, your Google Cloud Platform, and your AWS, that's your Amazon Web Service. So SIS for AWS, let's move into SIS for AWS. So the recommendations given by SIS for AWS have been divided into 5 sections. That's your identity and access management, storage, logging, monitoring, and the last one being networking. So in identity and access management, SIS recommends you to provide strong password policies, multi-factor authentications. And in your second part, that's your storage, it recommends you to make sure that your data is encrypted and not publicly accessible. In logging and monitoring, SIS recommends you to provide you with alarms and do event tracking and also provide threat intelligence. In the last part, SIS recommends you to on what traffic should be blocked and what should be allowed into your cloud environment. So we'll take a demo into practical attack into consideration. So we are going to take a poorly configured S3 bucket as our scenario here. So firstly, S3 is the simple storage service that's provided by AWS to store data. So data can be stored in the form of files or objects in files in the form of objects. So these objects are stored into your S3 buckets. So these objects can be hosted on any website, and the objects from the website can be stored into the files from the website can be stored as objects into your S3 buckets. So if you poorly configure your S3 bucket, a hacker can gain easy access to this bucket and access all your objects. So let's look at the demo for this. So I'm going to go to our DPalmer's demo website. So what a layman would usually do is he would just go through the website and check for the required information and then close the website and go. But if you think from a hacker's perspective, he'll try to view the page source of it and try to find anything interesting here. So the page source basically provides us with the HTML source code. Over here, I'll try to find if any S3 buckets are found. And bingo, we seem to have found an S3 bucket here. So when I click on this, the logo pops up as your object here. So according to AWS's naming convention, first comes the domain name, then comes your bucket's name, and then is your object's name. So I'll take this bucket's name and see if we can find something interesting. So over here, I'm going to go into the command line interface, and according to AWS CLI, so AWS S3 LS provides us with the objects that are found in your S3 bucket. So over here, we can see that it's not just your logo.png that's found as the object here. There's also another object that's your demo website credentials.csv. So I'll just copy and paste the object name here and remove the logo.png object. And it's seen that one file is getting downloaded here. I'll just open this CSV file and see what's inside. And it's seen that we are getting the password, the access key, secret access key here. This seems to have been the credentials of an IAM user. So it's found out that not just the S3 bucket, but also the objects that are present in your S3 bucket are public here, just because of one poor misconfiguration. So SYS provides us with recommendations for these kind of attacks. So SYS provides us with the recommendation by providing the description, rationale, audit, and remediation. So moving on to the remediation. So SYS wants us to make sure that the block public access is always enabled. So by enabling block public access, your objects as well as your S3 buckets are not public anymore. So you move on to your S3 buckets that public and go to the configuration block public access. And over as seen in our S3 bucket, it was publicly accessible. So we move and enable block public access so it's not public anymore and save the changes. So you might ask, what's the default settings provided by AWS for these kind of cases? So AWS makes sure by default that your block public access is always enabled. But sometimes, as we wanted to show our logo.png, that's our object, so we had to make that object public. But sometimes what developers do is they don't just make the object public, they make the entire S3 bucket public. So all the objects that are present in that S3 bucket in turn becomes public.
So now we saw why it is important for us to make sure your S3 bucket is private. Let's look into a few other cases, such as making sure your S3 bucket does not take any requests from HTTP, or making sure your CloudTrail logs are encrypted with some sort of KMS keys. And then there are around 56 plus cases that has been recommended by SYS, which is very important for you to make sure your cloud infrastructure is as very secure. Now let's look into few more cases. Let's say your RDS instance is public, or your security groups and ports are set open, or your EBS volumes snapshots are made public. These cases are not found in your SYS benchmarks, but are highly recommended to make sure your cloud is secure. This is the reason why we should be going above and beyond SYS standards to make sure your cloud is as secure as possible. Let's look into the Capital One attack and see what exactly happened there. So the Capital One attack, the attacker was an ex-employee of Capital One. They knew that this Capital One website was hosted on an EC2 instance, which had an open port. And the Capital One website itself had a SSRF vulnerability. So this made the attacker gain access to the EC2 metadata service. Now this service allows you to get access to the role that has been attached to your EC2 instance. Now this role can be attached to any other AWS service as well. So in this case, the role was attached to an S3 bucket, which allowed the attacker to get access to the S3 bucket. Even though this bucket was made private, through this role, the attacker could get access to the information which was compromised in an overnight. Let's look into another example where you're making sure your RDS instance and your EC2 instance is only accessible using one VPC network. Let's say that this RDS instance is poorly configured, and let's just say this attacker knows an connection string or the password for this RDS instance. Now, if this RDS instance is poorly configured, the attacker can easily get access to the information or the database present in your RDS instance. Let's look into this exactly how. This attack was actually seen in an Fortune 50 client. I'm going to open my SQL Server Workbench which allows me to connect to any RDS instance using a connection string. Let's say I am the attacker here, who can be an ex-employee who knows this connection string already. So it asks me to give a host name. I'm just going to copy paste the connection string I already have. This also follows the Amazon naming convention. First being the RDS instance, second the region, and the third being the domain name. I'm going to keep this connection name as demo connection and try to connect to this. It's going to ask me some password. Now, if you haven't changed your password or have kept it as a very predictable one or a default one, it is very easy to get access to your RDS instance. Now, you can see that within seconds or minutes, I'll be able to get into the RDS instance. And voila. You can see there is one database in this RDS instance. Now, if this was a connection string to an multinational company organization, they would have had multiple databases, millions of tables, and a lot of information in each of these tables. Now, I can just click onto this database and see there are a few tables. And I'm just going to try look into one of these tables and see what it has. So this employee table seems to have few of the personal informations of employees. I can easily even change the data present here, or I can delete this, or even delete the entire database for an instance with just a click. So you can see, this is how easy it is to make sure your RDS is easily detectable. Now, this all could have been prevented if you had just gone to your RDS instance and make sure your connectivity settings has an additional configurations called as not publicly accessible. Now, if you had turned this on, it wouldn't have been possible for anyone to access this RDS instance. Usually, by default, this is not publicly accessible. Nowadays, due to pandemic, most of the employees tend to work from home and will not be able to access this RDS instance because it is not in your VPC. If you want it to be accessed beyond the VPC network, then it should be publicly accessible. The DevOps engineers just make it publicly accessible to make it their work easy, and which is not recommended basically. So to tackle all of these problems that we face in your cloud infrastructure, we have come up with our own approach to create a powerful monitoring tool that automatically detects the misconfigurations present in your cloud infrastructure. It only focuses on your cloud infrastructure and nothing about the web API or the API security part of it. What we have done is compiled cases that are SIS recommended and the cases that go above and beyond SIS, which we have compiled this to create our monitoring tool that majorly looks into 5 sections, that is IAM, logging, monitoring, storage, and networking. So these sections, and it produces 3 major solutions, one being a summary dashboard, second a detailed report, and the third being a CSV file. So the summary dashboard looks into the statistical details and overall security posture of your cloud. The second, the detailed report will tell you why and how and where exactly it went wrong and pinpoints to the misconfiguration present for you to configure it properly, easily. So the third is a CSV file, which can be easily fed into other tools such as Jira or Jenkins or any other bug tracking tool. So this tool looks into, detects misconfigurations in your AWS services such as S3, EC2, and many other services. It takes Boto3 SDK for which used for connecting to your AWS account. And as of now, we are able to scan for 60 plus misconfigurations and report the same. So let's look into our demo on how our tool works. We have tried to make it as easy as possible. All you need to do is configure to your AWS account using AWS configure. It's usually asks you to give an access key ID, secret key ID, and other information. I've already fed into it, so I'm just going to click away. It asks you to give a region name and the default output option. So I'm just going to keep it as JSON. Now all you need to do is run a main Python file, which is in one of this location. I'm just going to copy paste here. It's Python. So you can see that the scan has been initiated. It will take some time to run. By then we will look into the setup and configurations of our tool.
So to configure, as Maithri said, we have to do AWS configure. So the credentials that have been taken here is the security audit credentials. So the security audit credentials basically means that we are only provided with permissions to scan and check the AWS account. We have no access to the data present in the client's AWS account. So after taking the security audit credentials, we run this on our cloud and provide you with the 3 output results. So as of now, we have 60 cases that have been implemented, and for the future, we want to make sure we add even more such cases that provide us threat intel to such misconfigurations found in our AWS cloud environment. We would also like to span across other cloud platforms like Google Cloud Platform, Microsoft Azure, and many more. So
Let's see if our tool has run by now. I think it's going to take a little bit more time. In the best interest of time, I actually ran this before our presentation to show you the outcome. All I need to do is so this is how our dashboard looks. It scans and tells you the total number of cases that the tool has run. It mentions the total failed cases that have misconfigurations, the number of cases that passed, and the number of cases that couldn't be scanned, mainly because we don't have enough authorizations to look into the configurations of any service. It also looks into the severity in different sections, that is IAM, storage, logging. It also mentions the total number of resources that were scanned from the AWS. Currently, there were around 315 in our account, and it looks into the IAM users, EC2 instances, or the alarms, VPC, and other 16 other services in total. It also shows a vulnerability trend chart. It gives you an overall security posture view of your cloud infrastructure from each scan to scan. It can take up to last 21 scans can be shown on this thing. Lastly, it also shows a detailed report into where the problem lies. If it's a failed case, it shows the case that has been scanned and the service for it. If this has been a failed case, it also gives you a small notes on where exactly it went wrong and where you should focus your efforts on. So these were just our backup slides for now, just in case it didn't run.
So to summarize our entire presentation today, we first spoke about web application securities for the web apps that are deployed into our cloud environment. We saw how the web apps API and the portals are securely configured using SDLC and Secure Scrum. But we saw how cloud infrastructure security is an often neglected topic and how it has a larger threat surface for exploitation, especially in mid-size and small-size businesses, as more workforce cannot be employed for this reason. We saw that manual evaluation is not practical for such kind of scenarios, hence we need automation. We saw the different industry standards like CIS benchmarks, your CSAs, that can be used. And we also saw how we have to go above and beyond CIS benchmarks. And we also showed our tool that was taken for AWS as our POC. And we showed you the 3 output files. So thank you. And the floor is now open for questions.